it swings, it possesses kinetic energy. As we started the other time, the conservation of energy or the transformation of energy, you could see if it stops, it possesses what we call potential energy. And with the potential energy, it is the mass. Normally, some of us will say the weight of the object. Plus the acceleration due to gravity that reacts on it. Plus the height. Look at the height of it. And never change either a potential energy. But as it moves, the height will change. If you move to this side, the height changes. If you come to this side, it changes. To this side, it changes. So that it goes like that. So here it has an end point. You see, it's a potential energy. Then it moves. The potential is, so look at it. It's potential. But as it moves, kinetic. You can say more position there from back. Okay. Yes. Oh, I'm not going to say a baby say. Yeah, we leave it like this. Yes. Say like this. So let us start you like this. We leave it now. What will happen? Have you seen that it is distancing from me? Yes. It is moving away from me. But meanwhile, when it started, it was right in my chest. And it died. And that's the energy. So the energy keeps reducing. Okay. So the people are it's a simple pendulum. As we read the other conversion of energy or transformation of energy. And the law of conservation of energy says that energy cannot be created nor destroyed, but can be transformed from one form to the other. And we use electric iron for an example. And we also look at a carpenter hitting a nail with a hammer. Do you remember that? Yes. Yeah, so today we are going to demonstrate that with a simple pendulum. And we said a pendulum consists of a ball. And it can be a metal ball. So let's take this for our ball. With a string tied or with a rope tied to it. To leave it to suspend. So it is suspended freely. Now, whenever it stops like this, we say it is at rest. It is at what? Rest. Your glass. Rest. Again. Rest. Now, if it comes to this time, it is at rest. When it is at rest, it possesses an energy. And whenever you swing it, we say it is in motion. Say motion. 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 Motion simply means that it is moving or movement. That it is swinging. Now, if the simple pendulum is at rest like this, it possesses an energy called the potential energy class. Potential energy. Again. Potential energy. Elijah, it possesses what type of energy? Potential energy. Why are you laughing? Potential. Okay, so potential energy. That's it. So, the potential energy simply means that whenever an object is at rest, that the object does not move or is not moving. So, object like me say like this. I possess potential energy. But the moment I start to move in motion, I possess what? A kinetic what? Energy. So that's the simple pendulum. So it possesses what? Potential energy. So if you leave it to swing, what type of energy does it possess now?
Kinetic energy.
New class.
Kinetic energy.
Again.
Kinetic energy.
And you can see that as it swings like this, it stops, then it moves. It stops. It has an end point. An end point. Now, if we break that end point for it to stop, before it swings again, that energy there is also potential energy. But as it moves in between the two potential energies, we have the kinetics. That's the kinetic energy. Now, for us to be able to calculate potential energy, we will say that the mass of the object, of this object, multiplied by the acceleration due to gravity, it can be suspended as SSL, though it has a rope tied to it. But there is a force of gravity that is pulling or working around this ball to make sure that it never falls. It is force of gravity. The earth's gravitational pull, a pulling say mental force. But being suspended, it has mass. You just say gravity is working on it. Then also look at the distance from the floor, from the ground. Hello.
Hi.
Distance from the ground to where we have the ball becomes the height. Say height.
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 So for us to be able to calculate potential energy, we are going to take the mass of the object multiplied by acceleration due to gravity that is working on the suspended ball, then we will multiply by the height of it. And if you take of it, and with the gravity of the acceleration will always be given to you, and it is always intense. Meters per second square. And if you use acceleration to gravity. So in the exam, I'll give you to say, so take acceleration due to gravity to be J is equal to meters per second square. So that's acceleration. Any question? Any question? Now, let me demonstrate lastly with this. Now, this is my simple pendulum. I have it on my chest like this.
Yes.
And I'm going to leave it for it to swing. So that we will look at something. We will observe critically. Let's observe. Did it touch me?
No, sir.
So you see, now right from my chest, now it is giving me some distance. And it is coming to a stop or a halt. Bit by bit. Bit by bit. So you see that the energy it possesses is decreasing. The kinetic is decreasing. The kinetic energy is decreasing. Is decreasing. And within a short period, it will stop. Or it will come to rest. Now it is in motion. It is in motion. This is how the simple pendulums work, and this is how energy is transformed from the potential to the kinetic in or using the pendulum as an example. Any question, class? Any question? So should I ask you a question? So if in the exam I ask, describe a simple pendulum. Question 3AI. Oh, sorry. The II part will be that I will draw this pendulum. Then I will take it to this position like this. And I'll write say A. I'll bring it to this side. I'll write say C. Then to this side, I will tell you D. Then a little bit here E. I'll ask you. Name the energy possessed by the pendulum at position A. Hello?
Hi.
Are you here with me?
Yes.
Yeah, then what can you hear? I don't want you to answer now. You don't know why. Yes, really concerned. Yes.
What?
I'll ask you to name the energy the pendulum possesses. Now, there's one thing I nearly forgot. Now, as it swings, the correct term is oscillating. Say oscillating.
Oscillating.
Oscillating. It is a comma 1, 2 hour. First oscillation. 1, 2. Second oscillation. Sa na ekoba sa. And as it moves, it oscillates. Therefore, it does a complete oscillation. Okay, thank you very much, and I hope the other groups will get your things ready. Those who are constructing a simple pendulum with different or with about 3 or 4 pendulums already, make sure you get that project ready. And those of us who are working on the electrical energy should also make theirs ready. And finally, those who are working on the solar energy too. Then from there, we will go to the hydro energy. How to get electricity from water? That's the hydro energy. So from in our next meeting, I'm going to take that the 3 project works, that of the solar energy, that of the pendulum, and the last one is the electrical energy using the dry cell, the connecting wires, and a switch and a lamp or a bulb. Thank you very much. You can go out from here.
This is the simple pendulum. This state is potential. When I leave it and it is swinging, it is kinetic. And when it is stand,
Stand there. Stop.
when it is stand, it is potential energy.
Profit drum pa.
Class. This is a simple and it is a stage of potential. But if I leave it and it's swinging, it's a stage of kinetic. And if you stop, it's at the stage of potential again. Electrical energy. We are coming. We are coming to join the wires to the cell and make it join. We are going straight to the language.
Turn the wire. 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 Turn the wire.
Today I will say
Of course, I'm saying.